The next way we can combine statements is called a conditional. In a conditional, we're thinking of one statement depending on another. And because the way that we do this in formal logic is a little bit weird and tricky, I'm going to start out by giving you the truth table, and then we'll try to make sense of this. P and Q are combined using a conditional, written P right arrow Q, so we see this, and read as if P then Q. So we see P right arrow Q, and we say if P then Q. The combined statement here is false only when the first statement is true at the same time as the second is false. So in this truth table we see P is true and Q is false. Then if P then Q is false. The rest of the time, the conditional is true. So if we see that Q is true, if P then Q is going to be true. If we see that P is false, if P then Q is going to be true. Now, this is unlike the two previous combinations that we've seen, right? Notice that in the conditional, order matters. Because the order matters, we have a way of talking about just the first part or just the second part. They have separate names. And in math, when we give pieces separate names, that's an indicator that the order they come in matters. The first part, P, is called the antecedent, though we'll often just refer to the if part, because our goal here is to understand the logic, not to necessarily master the vocabulary of formal logic as if we were in a logic class. The second part is called the consequent, but we'll often just refer to that as the then part. So the antecedent is the if part, the part that comes first, the first simple statement. The consequent is the second part, the then part. We think of the consequent as being a consequence of the antecedent. If the antecedent is true, that forces the consequent to be true. So let's consider a mathematical use of this if-then. Suppose I'm thinking of a number. If I'm thinking of the number 6, then I'm thinking of an even number. So if I'm thinking of the number 6, then I'm thinking of an even number. This is made of the simple statements, I'm thinking of the number 6, and I'm thinking of an even number. And we can symbolize it as if P, then Q. Now, this statement, if I'm thinking of 6, then I'm thinking of an even number, is true no matter what number I'm thinking of. Why? If I'm thinking of the number 6, then I really am thinking of an even number, because the number 6 is even. If I'm thinking of some other number, well, it could be any other number. It could be either even or odd. So that means knowing P is false doesn't tell us anything about whether Q is false. So knowing P is true tells us that Q is true. Knowing P is false gives us no information about Q. That's why we define if-then in this way, so that if the antecedent is false, it doesn't tell us anything about the consequent.